Hello everyone, welcome back. And yeah, we are at the final session now almost. I have Callum here, welcome.
Hello, nice to see you, Mark.
Yeah, it's been a long time since we've seen
It
each
has
other.
been a long time, and probably it was virtual because it's great. It's great
Yeah.
finally to have people back in person.
Yeah, exactly. Yeah. I did once also attend like a Dugfest, I think, also in
Yes.
Utrecht. I think that was the last time I were in
Yes,
real
quite
life.
possibly. Yeah.
That's really quite some years ago. I definitely need to attend the next time again. That was super awesome.
Yeah, it's a great event. It's always a great event. And it's great to be in Utrecht. And haven't been here for a few months. Nice and I've heard the sun's come out for us.
Yeah, that's the best excuse. The weather is always so good here. No. Today we're talking about scaling in Azure.
Yeah, and with .NET apps, but not really .NET apps actually. It applies to anything. So
Anything. Okay.
anyone that's watching, you can take these concepts and you can
Okay, that's
you
good.
can use them broadly.
All right. Yeah, no, I'm super curious. I would say let's get started. Get ready at your laptop, and we can get going. So yeah, well, Callum is preparing. Please hold on for this one final session. Going to be like a super interesting technical one. Quite a contrast with the previous one, but I think it's nice, all this diversity in speakers and sessions. Yeah, I think Callum is ready, so go ahead and enjoy this final session, everyone.
Fantastic, let's get started. Okay, well, as Mark's already introduced me, I don't have that much to say here, but I'm Callum, and I'm going to be talking a little bit about scaling your application with Azure, or maybe we have a saying in the UK, 3 ways to skin a cat. 3 different ways to approach scaling in Azure. And if you're doing JavaScript, if you're doing Python or Java, actually all of this applies. So hopefully there's something in this for everyone. Just quickly, a little bit about me. As I said, my name's Callum Whyte. I'm quite active on Twitter. If you like to get hold of me after this, I'm a Microsoft Developer Technologies MVP, and Umbraco MVP. Umbraco is an open source .NET CMS. If you don't know, it's a very good one. You should go check it out. I do .NET development. I run a small web agency in the UK, working with Umbraco. I speak at events, organize events. Love donuts. I'm trying to cut down on a bit of a health kick at the moment, as a few of us are in the new year. But yeah, that's me. So we often, in our line of work as engineers, get asked about scaling, right? And scaling is a topic that people often get wrong, or maybe just think it's going to be super easy. And it's not. It requires a bit of thought. So in today's session, I'm going to explore 4 areas, or 3 to 4 key pillars of scaling your application. These are the different constraints you're going to have, the different challenges you're going to come up against when scaling an application. The first one's compute. So this is your amount of compute power behind your application, what's needed to run your application at scale. Of course, the more your application's in demand, the more compute you are going to need. Scaling that is a challenge within itself. Persistence, data. What do you do with your data at scale? How do you handle, multiple requests, writes, geo-distribution of that data? It's a big challenge, and something that maybe shifting a legacy application to a cloud platform or trying to scale that isn't going to be so easy to do. State is a tricky one, and that's why I've graded out here. We're not going to touch on this too much today. State is very difficult to do at scale, and doesn't really apply to every context, which is why we're not going to talk about it so much. Let's say you're building a big e-commerce system with logins and people's baskets and tracking of checkout sessions. Well, okay, yes, state's really, really important there. If you're building a, let's say, something like IMDb or Wikipedia, where you've not got that much ongoing, say, edits or sessions, it's mostly read-only traffic, well, state doesn't matter so much in that case. So we're not going to talk about that one today, because that could be a whole talk in itself. And finally, the third pillar is observability. One of the biggest challenges, and possibly the most important of the 3 here. This is the when and why you scale, not the how. The other first 2, persistence and compute, are really going to be more about how do you scale, how do you get your compute to be multiple instances, how do you get your data storage to be able to handle lots and lots of requests. Observability is when and why do you need to perform actions that will make compute and persistence able to handle all the traffic. So just as a bit of an example, we've got a few different forms of compute in the Azure world. Let's say we have virtual machines, which would be maybe the legacy approach to having compute. This is virtual machines are running an operating system. You install whatever software you need, and you host your application on there. You have app service, or like a PaaS type platform, where you can chuck your code at the platform and it sort of runs it. And it can handle things like scaling as well quite nicely. In the virtual machine world, scaling is semi-automated, but you still have to roll out physical hardware, or virtual hardware in this case. With an app service or a PaaS platform, those apps get provisioned on as many machines as you need, and you can scale up and down pretty dynamically. Quite cool. There's also another paradigm that's maybe somewhere between app service and this next option, which would be a serverless option. And we're not going to touch too much on that today, but it's a similar concept to app service where compute is provisioned as you need it. And finally, Kubernetes. So Kubernetes is a container orchestration tool. And we're going to touch a little bit on what that means and how that works in practice in a second. But Kubernetes is a way of deploying multiple instances of an application running in containers across many, many virtual machines. And it will sort of manage that for you. Azure has a fantastic Kubernetes service that is great for managing Kubernetes clusters at scale. And they've got some other flavors of Kubernetes running in the cloud as well, which we're going to have a look at. For persistence, so maybe the more standard, typical thing, if you had a physical server, you're going to have physical spinning disks. People still have those running in data centers in places in the world. Disks is probably the most common form of storage you'd be aware of. You have a disk in your computer that's storing all of your data there. Now, in the cloud, we maybe have a more modern approach to something like disks, which would be a service like blob storage, or in this case, a managed storage service. So rather than this being disks that fill up, you've got almost infinite space there, and those get spread across multiple disks in Azure's data center and could be distributed globally if you need them to as well. The blob storage service is part of a storage account. A storage account can contain tables, it can contain blobs, files, loads of other stuff. And again, geo-distribution, replication, fault tolerance, all the stuff you don't get from disk. If you had to have disk, if you wanted to do the same with disk, you'd have to manage all of that stuff. And this is kind of the same with traditional SQL or relational databases. If you're using a traditional database, those typically don't scale very well or scale globally very well out of the box. So you have to come up with some alternate solutions. Now, Azure SQL is the preferred for us way of hosting SQL databases in Azure. But you can do a lot of stuff with this as well. It can scale, you can do data replication, it can do fault tolerance, but it's not quite as good as its cousin, should we say, from another planet, Cosmos DB, which is a kind of an anything DB. It has graph storage, it has relational database storage, it has NoSQL style storage. It can kind of do everything, and it's geo-distributed. And it's, all powerful. Where the Azure SQL, with the approach with Azure SQL, you're sort of, again, resource constrained based on requests, inbound pipeline. Cosmos DB will scale, in theory, infinitely for you. So depending on where you want to store your data and what types of data you have, any of these options could be viable, but each one comes with its own challenges. So if you had media that you need distributed globally, well, blob storage is probably a great shout. If you have some relational data that maybe doesn't need to be high query volume or doesn't need to scale so much, Azure SQL is great. If you want to pay a little bit more, maybe have geo-distribution, maybe you're going to have multiple reads and writes simultaneously in different places all over the globe, well, Cosmos DB is really great at helping you out there. Again, you could probably do a talk on each of these options on their own, so we're not going to dwell too much on the individual implementation of these products. Finally, observability. What are our tools in Azure? Well, we have two main tools. Azure Monitor, which is one you've maybe not heard of so much, and Application Insight. Application Insights is a log analysis tool. You can dump all of the information about your application into one place and then start to action things based on it. Or if you're, say, running an application with 15 different servers and you need to get some logs from a very specific server, you don't want to have to go and find that server. Or if you're running in a PaaS setup, you don't have a server to go and log on to. You don't know necessarily where those logs are. This allows you to keep all of that data all in one place. and get a really good understanding of the health of your application at any given time. Now, Azure Monitor is sort of underpinning every Azure service. You've probably seen this or interacted with this without knowing. If you go into the Azure portal and you go to a web app, you'll see the sort of CPU usage or the traffic, the number of requests. Now, that's Azure Monitor doing its job. It's keeping an eye on every single part of the Azure infrastructure. You can then set up more specific alerts and actions if you wanted to there as well. Again, probably a whole talk on that. We're not going to go into it today. Right, so the when to scale. As I said, observability is possibly the most important bit. You can throw metal at your website or your application to make it scale. It's not necessarily going to perform very well, it's not going to be easy to maintain, and you're not necessarily going to be doing the most efficient thing in that case. So this when and understanding when the right time to perform these actions is really, really valuable. So these are some common scenarios that I've seen people decide they're going to scale their application. By request count, so you know that, hey, our application handles roughly 1,000 requests, and then it needs to scale up, or maybe many more, maybe many less, concurrence, that is. However, that's a problem because requests are not all made equal. Some requests are a simple, if you think in web request terms, that's an options call to an API is going to be very minimal amount of data, versus doing posts that then have to write data to storage or go fetch other data from other systems. Those could be, they're not going to be equal. So you can't accurately measure or quantify really how many requests your application can actually handle. You could maybe do it for each type of request, but then that's going to be a nightmare. You have a whole other observability problem if you need to know scaling based on certain numbers of types of calls. So that's one thing, probably not the best option. The other ones are by performance. So you could monitor with a tool like Azure Monitor times to respond. So if you have an API, how long it takes on average to respond to a call, or how long your database calls take, those sorts of things. But this is also a problem because if you depend on a third-party system, or you depend on a Microsoft service that maybe has an outage, scaling may not fix the problem if there's a problem with one of those external services. Yes, you should try and mitigate those, but again, this is tricky to determine. Equally, coming back to that example I gave a minute ago, a post request with lots of data is probably going to take a lot longer than a simple GET request to hit the cache. They are not all equal. You cannot necessarily choose based on that you want to scale. Resource usage, interesting one. Ideally, in an ideal world, you would optimize your application so you're using as few resources as possible to run. But again, sometimes someone releases some code to production, you get a memory spike, or it's not been quite optimized as it should, and your thresholds get hit, and then you have to scale up. Does that mean your application's at danger of crashing if you don't? Well, probably not. Maybe your thresholds just set wrong. I've seen people setting their resource usage thresholds for, say, scaling far too low, 60%. And then you have a highly memory constrained application. Well, if you're trying to put as much data into memory as possible, you will be using probably 60% of the available memory in your system. If you've got a CPU constrained application, maybe you're doing some machine learning, well, actually, you're probably going to use most of the CPU. So you've really got to decide what metric you're trying to measure there and how you're going to quantify that your resource is being maxed out. The final one is maybe on a schedule, but I'd hope you're not really doing this in production. It does make sense for some workloads. So if you have tasks that need to happen overnight, perhaps, you might scale those up in the night and scale them back down in the day, and equally scale up certain resources during the day when users are using your system, scale them down at night. But it's not so resilient because for that one or two times where something does happen in the day and you need to add more resource or need less resource, it's kind of tricky. Manually, I really hope no one's doing this, please, please, please. But everyone's probably been in that position where marketing come knocking on the door. Hello, we just sent an email out to 1 million people. That's going to be fine, right? No, probably not. But in those cases, you can scale manually. I think the real answer here is it's a mixture of all of these options. You've got to find which one fits your application best, and you've got to find which one fits your use case best. If you have predictability around your usage patterns, then yes, you can maybe go for more of a scheduled approach, more of a proactive approach, shall we say. Whereas if your traffic spikes are completely unpredictable, then you're going to need to be more reactive. So one of the first few options there are probably better. I don't know why there's a black screen there. Right, I'm going to give you a sample application. I've done a longer version of this talk where we've got a proper working example and a demo. I'm not going to go into that today, but this is my sample application. And it's been very specifically chosen for several reasons. Firstly, it's Umbraco. I love Umbraco. I mentioned that. But secondly, it's actually a kind of perfect example because we have a .NET 6 app. And that's just a regular .NET 6 application. There's nothing special about it. It's got a database connection. It has some files that are stored on disk so that I can run my website. So here I have a Azure VM. It's set up. It's got an SSD there where I'm storing my assets and my logs. And my SQL database lives on the same server in MS SQL. And I have a DevOps pipeline that's building and deploying those things, but that's not really a big deal. This is a standard setup for a small website, shall we say. Now I've made it big time. So how do I scale this? I need it on multiple machines or in maybe multiple locations. What am I going to do here? Well, we have got some options. In Azure, we could use web apps. It's platform as a service. I don't have to manage servers or VMs anymore. I don't have to worry about patching. That's all good. I can manually or automatically scale my application as and when I need. That's great. Instead of having my SSD with all of my files on it, which is, well, one, not very fault tolerant, but two, can't be geo-distributed easily, I can put that on a managed storage service like blob storage. For my database, that doesn't need to live on a VM either. That could live on a managed database service like Azure SQL. And for all of my logging that was previously stored on that SSD, I can also put those on something like Application Insight. That's a really easy way to start mitigating some of those infrastructure dependencies I had, where I'm kind of relying on stuff being available on my server, and make them a little bit more scalable and reusable. I will quickly show you, just as an example, what Azure Web Apps actually looks like, in case you haven't seen this, and here's sort of how we would go about creating an application. So I've created a few resource groups here. In this case, called VACD app. I'm going to go to Azure and I'm going to search for an app service. And you can then provision. The search in Azure has got really bad. App service plan, which is, if you want to think of it as a server, you can think of it as that. It's a block of compute. A web app is a way of deploying, it's a type of application that will run on app service, on that compute. So in this case, I have my web app. When I click that, I can go through the steps. I can decide which resource group I want to create it in. I can give it a name. I can choose a source for the code and the files that I'm going to run. It could be my own custom code. I can push to it with Kudu. It could be a Docker container. They've got static web apps as well. A bunch of runtime options, and we're good to go. Now, I've already set this up because it does take a couple of minutes to run. So I have a very simple web app with nothing on it. This is just the first welcome to your web app screen. So yeah, that's that. Now, if I wanted to scale this, I've got built-in options for scaling. So I don't have to worry too much about handling that myself. I can either scale up, which means put my app service plan on a more powerful plan. I'm on the S1 tier currently, but they've got SP, they've got development tiers, testing tiers, a free tier even, and all the way, it can go even further. So yeah, I can scale up my plan, or I can scale it out. Scaling out is adding more replicas of my application. This could be done manually, as I say here, just drag, or based on a rule that I define. So here, I can start to set up my conditions. So add a scale condition. There we go. So in this case, nope, not what I wanted to do at all. There we go. So you choose the mode that with which you'd like to scale. In my case, I'd like to scale up by one item, but by one instance, based on a metric that I choose. Now, these metrics are powered by Azure Monitor. So all of that data is being fed into the Azure platform constantly. You remember back to that slide where I was talking about all the different options you could choose to scale by? Well, here they are. You can choose the amount of data coming in, your HTTP queue length, which is quite a good metric. because that's how many requests you've got waiting to be serviced by your app service, meaning people trying to get through that can't right this second. Memory percentage stuff. Memory percentage, CPU, they're the ones you want to be really careful with, because as you can see here, my value was 69% constantly. I think that's an error with the graph, but that's not really a problem. If I'd set my scaling metric to 60% and I scaled out to another app, well, it would scale out again straight away to another app and another app and another app infinitely, because my application regularly uses 69% of memory. Same goes for the CPU. So yeah, just choose those metrics carefully. You can choose your conditions, the rules within which it should scale up or down, and then you're good to go. And it's genuinely as easy as it seems. So yeah, that's scaling with an app service in web app. Now we have another option where perhaps if you wanted to unlock another tier of hosting options here, Kubernetes for one, or perhaps you've just decided that you've containerized your application, you'd like to ship all of your application within a container. You can run containers on web apps themselves, so you don't have to deploy your code straight there. You could deploy your whole container, and that could contain anything you want. So if you want your database to live inside the container, it can live inside the container, or other infrastructure dependencies, perhaps a queue or something like that. So the exact same setup as we had before, exact same code, but it's now containerized. That's possible to run in Azure too. I've got another quick example of that, where I've got a container-based app spun up. When I created, instead of choosing code, I chose Docker container, and I can choose a source where that comes from. This is a containerized app. Doesn't really say as such, but you'll have to trust me that it is. Thankfully here, scaling options are exactly the same as they have been in the web app, because they are either based on manually scaling up or scaling out. It's probably the easiest way you can deploy and scale a Docker container in Azure. If you're going to run it for, say, a website or something, this is probably the easiest way to do it. Same metrics, everything you had before, super powerful and super user-friendly. So where do you begin? If you want to containerize your app, you have to think through a few different options. Docker's generally the preferred containerization tool nowadays, and Docker's pretty straightforward to get started with. The first thing to do would be to install Docker and create a Docker file. Now, for me, as someone who doesn't know anything about Docker really at this point, that's scary. But there is a Visual Studio extension. When you've installed the Docker desktop application, it adds an option in the dialog, so you can click on your project and say, add Docker support. And based on you having .NET, or depending on what you've got in your project, it will create the relevant Docker file. So I didn't have to do any work. I was able to get a demo of this working where I didn't have to write any code or any configuration. I don't have to worry about YAML, those sorts of things. So then we have to package up our application. This puts our code inside the container and allows it to run. We then need to store our container somewhere so that we can deploy it. That's called a registry, and then we deploy that from our registry, our Docker image, into the real world, onto an orchestrator for it to run. You can do this with the command line. So Docker build will package up our app. -t here is a tag, and that gives your package a name. I'm here just calling it app latest for something generic. The dot there is symbolizing that it's the current folder that I'm in. You can then run your application. This is worth doing before you try and deploy it, just to make sure it does actually run as you'd expect. And then you can push that to a registry. So Docker push, give it a name of a registry. There's plenty of registries. You may have heard of Docker Hub. Azure has a fantastic one called Azure Container Registry, which on the basic tier is free to use, up to 10 gig of storage, I think, and it's pretty generous, and it probably meets most of your needs if you're only deploying Docker in a small way in Azure. And then finally, you want to deploy your image. So just like I showed you a minute ago, we can deploy a web app on Azure, and that web app allows us to select a Docker container. And I've just chosen a region there. I'm not that worried about any of this. When you come through to the next options, you can choose a source for that Docker image. yes, I can take a off-the-shelf standard example, or I can choose from one of their registries. So container registry already integrated. It's worked out that I've created a container registry called VACD containers, and because I've not deployed an image or a tag there yet, it won't be there, but it would be my app, would be my image, and latest would be my tag, and away it goes. Alrighty, so the second of the three options we're going to look at for deploying and scaling our application was Azure Kubernetes Service. As I said at the start, Kubernetes is a managed, is a container orchestrator tool. It allows you to deploy instances of your Docker container, or any container for that matter, across many, many physical servers, which are called nodes. You have two concepts that we need to get our heads around here, where in web apps, we were talking about scaling an app. That's a single instance of something. Here we've got two things we can scale. We can scale clusters, and we can scale pods. Now, a cluster is your physical machine, the number of VMs with Kubernetes installed connected to your network. So that could be 5, 10, any number, thousands of physical virtual machines running in Azure with Kubernetes installed. Then you have pods. Now, pods are instances of your running container, and that number of pods gets distributed across your cluster. So, in theory, if you have 5 nodes and you have the pod, one pod, but it's scaled out to 5 nodes, you'll have an instance of your application running on every single node in your cluster. If you wanted to go further, you could scale that even more. You can have multiple different pods, so you could have different versions or different infrastructure components running in pods on Kubernetes and scale those accordingly. You could decide, well, we've got a backend service that is just churning away constantly. It doesn't need to be that performant. We will say that pod can only be scaled out to 2 servers at a time, whereas we've got a front-end service, and that needs to be scaled out across the entire cluster and kind of take up as much resource as we can possibly give it at this point, and you can configure exactly that too. Because Kubernetes service is more designed around like servicing microservice type architectures, is not really out of the box geared up for servicing web applications, building a full publicly accessible application. It doesn't have any public DNS service as part of it, whereas the app service is already publicly available. So you have to put something like an application gateway in front of that application, in front of Kubernetes, for it to talk to the outer world. It does have an internal DNS service that will allow you to resolve requests to a given instance of your container running on a certain port, but yeah, that is Kubernetes. Now, again, very quickly, I've got an example set up of this running in Azure. So I was able to create a Kubernetes service, and I don't know a thing about Kubernetes. I don't want to have to write configuration. If I was hosting this myself, I'd have to manage all of that. I'd have to manage patching. In this case, Azure sort of handles that for me, which is quite nice. I can go up here and I can create either using YAML, or I can use one of their quick start templates. If you're going to use a quick start template, I can choose from an image that already exists, such as one that I've put in my Azure Container Registry instance that we spoke about a minute ago. Or I can just choose an off-the-shelf example. Let's choose an off-the-shelf example here. So it's giving me a nice simple example. It's going to give me a voting application, cats versus dogs. Which one do we prefer? As my example. It gives me all of the YAML configuration that's needed to run that application in Kubernetes. I don't have to worry about it. I can modify this if I wanted to and change the config if I know enough about Kubernetes. If I don't, you're pretty safe to just hit deploy and it will run. So in this case, I've hit deploy. Now you've seen here, it's already very quickly scaled that out to 5 different things it's deployed to Kubernetes. It's deployed the namespace, which is effectively the reference from my pods. It's deployed 2 backend services and 2 front-end services, which is really cool. And whilst we've been talking, it's already spun that up. I've clicked twice, and I've got a Kubernetes instance running an application on Azure. Give it a second, it will spin up, and we can vote for cats because they are evidently the best. Maybe it's going to take a little while. yeah, it was that straightforward. I will close that. There we go. Cat. Ooh, demo gods aren't on my side. Okay, you'll have to trust me. I have one that I made earlier, which is lucky. So when it comes to scaling in Kubernetes, we can do that manually. We can scale everything up ourselves, or we can we can add more nodes. As I said, I've only got one node actually running in my instance because I didn't want to have to set up loads and loads of VMs, but it was pretty straightforward to do. So I can add more nodes to my pool. I can change my running namespaces. I should have two because I have the ones I deployed earlier. My Azure Vote one, I guess, from 2 hours ago. That makes sense. And I can, start to change the configuration of all of these. Equally, my services, I can start to change those. That's my load balancer. If I wanted to scale these up, I can do so. It's pretty powerful. Where is the thing I'm looking for? I don't know. I think it's actually back on the overview. Never mind. In summary, though, with Kubernetes on Azure, you can set it to autoscale if you'd like to write the Kubernetes configuration to do so. If you want to use the UI and the out-of-the-box tools, you're going to have to do it manually or maybe through one of the Azure APIs. It's not out of the box going to automatically monitor your application, scale it. It's up to you to configure how you want your Kubernetes cluster to run. So there's a manual element to this one. Now, option 3 here is sort of a hybrid of all of the options we've looked at already. Azure Container Apps. It's taking a managed, almost serverless Kubernetes setup and abstracting away all of the configuration. So you can do everything you can do in like a web app, as in, here's my application, just run it, and it's still Kubernetes under the hood. It has an option to scale with something called CADA, which is Kubernetes event-driven architecture. That is effectively a way of writing reactive configuration to say, when this happens, when this event's broadcast in my Kubernetes cluster, you need to do these things. It's also mostly designed around DAPA, Distributed Application Runtime, which is the Microsoft runtime for building sort of microservice architectures. It's more designed around microservices. It's not really for building, say, a website, but you could if you really wanted to. The best thing, because it's a sort of serverless platform, is that you can pay for a very, very small amount of compute, and only the compute that you use. With Kubernetes service, that's provisioned 5 VMs, and you're paying for those VMs all the time, regardless of if they're being fully utilized or not. With this, you can do it in half-gig increments of memory and also in compute. You can then also change versions of your application running. They've got this concept of revisions, so you can have multiple versions of a container running, and say we're going to have 80% of our traffic use this one version and wait between the two. Very quickly, I'll show you how that works as well. So I have created a Azure Container Apps instance, a Container App environment, and under that I can add an app. I created one that we'll have a look at in a second. When I create my app, I can choose a source. So in this case, I give it a name. Let's just call it Virtual Azure Day. Give it a location, choose some settings, the amount of CPU power I need, the amount of memory I need for my application. I can then also choose the source of my application. In this case, it's seemingly only letting me deploy a Hello World app, so let's not worry too much. I have my Hello World app deployed, and it's here. So because the container apps is already kind of publicly accessible, it's given me a nice URL. It's not a friendly URL, but it has built-in DNS. So if I wanted to attach a custom domain, I could do so without having to configure and provision a application gateway, a bit like I'd have to with Kubernetes service. So that spun up a very, very simple welcome to container apps application. So how would I go about scaling this given app that I've got? Well, they have as I said, really nice way of managing revisions. I can go to my tab, I can have multiple versions of this. So I can deploy new container images and say, well, this is a new version of my app, again, from any source that I wish. And I can scale those and set the scaling for those accordingly. So you can say between these numbers, and it will work there, and set scaling rules. These scaling rules can be based on HTTP requests, so number of concurrent requests to my service, which if you're building a microservice application, it's a bit more realistic being able to say, yes, this service has one HTTP endpoint, and we know it can handle this much traffic. If you're building an application that has a lot, that's maybe less realistic. Based on an Azure queue, this is a really interesting option that isn't available, as far as I know, in the other options for web apps or for Kubernetes, unless you were to configure something yourself. So you can give it a queue that's in Azure and say, well, when my tasks are backed up like this, give it more power so it can churn through that queue quicker. This is, again, far more leaning itself towards a microservice architecture, but is a perfectly valid scaling metric, actually. And then you've got your custom rules, and these are all based on these CADA type rules. So you can have a a custom rule here, and you can set it all up. This isn't just for revisions. This applies generally as well. So I can set my own scaling rules for my application when it's running in the real world. This is a pretty nice hybrid, I would say, between Kubernetes and the configuration, where if you want to do anything special, you have to know about Kubernetes. But then what they're abstracting away from you there is the virtual machines and having to manage those, your cluster. Here, it's taken the app service approach, where it's a proper platform as a service. I can throw my container at it. It's serverless, so I'm not paying for compute when I don't need it. Truly scalable, kind of infinitely. I think my maximum here is just because of the plan that I'm on, but yeah, it should be scalable. So yeah, that's container app. Now, very quickly, a summary of the three options we've looked at. The app service, for me, is comfortable. It's plug and play. It's very easy to start. A few clicks. I don't need to know too much. I have my code written, and I can deploy that code, and it should just work. I don't need to know about containers unless I want to. I do have the option there as well. So it can be really simple, or it can be a bit more powerful. The auto scaling is really painless. You can manually scale if you want, up or out, but you can also automatically scale with the Azure Monitor-based metrics. Just make sure you know what those metrics mean in the real world of running your application. It includes public DNS, so if you're going to host something that needs to be publicly accessible, then that's great. And then for your other infrastructure components, you can just use the other Azure managed services. So managed database service like Azure SQL, or you can use, say, blob storage for your storage. Kubernetes service requires some Kubernetes knowledge. You have to really understand what you're doing there. Whilst they're abstracting away the management, you still need to run your Kubernetes cluster, if you will, and use it properly. The scaling is manual-ish. If you know what you're doing with Kubernetes, you can automate that within your cluster, but the actual scaling of your cluster is going to be pretty much manual. If you want to do anything publicly facing, you have to have a gateway there, which is another cost, but it's also more to manage. And then finally, if you're going to run other infrastructure components alongside your application, those may have to run within your Kubernetes cluster itself, or you could run those elsewhere. So you could run SQL as a pod, if you will, running in Kubernetes. But you have your own challenges there. And finally, for container apps, this is a sort of hybrid of the two approaches. You've got a platform as a service approach to hosting containers and your infrastructure, to hosting your any components, really. You could have your database living in there if you wanted and running on a serverless basis, or you could have your just different microservices, split your application out accordingly. The scaling is slightly different. It's fully customized if you want to go and understand CADA, and you can also do it based on HTTP or a queue, which could be quite helpful if that's something you're looking for. It includes public DNS out of the box, including domains and things. So if you're going to build something that needs to be public-facing in any way, then great, you can do exactly that. And finally, it's a PaaS or an IaaS product. To summarize on the pricing, this is where it gets interesting, because App Service is actually the most expensive. Whilst it's probably the easiest to use, you're paying for that privilege. You are paying quite a lot of money for constantly provisioned resources, whether you're using them or not. So the S1 tier, I think, has 1.75 gig of memory. And if you're only going to use half a gig of that memory, well, you're paying for the rest regardless. Thankfully, with something like the Container App Service, you're only paying for exactly what you use. It's purely serverless as a platform. So that's maybe a little bit more cost efficient if you want to invest in the upfront cost of setting your application up in a containerized way and making all that stuff work. And Kubernetes service, I've said here it's the sort of medium priced option, but I'm not sure if that's always the case. It is the case if you're going to run it yourself and maximize the infrastructure. You're still provisioning a number of virtual machines. If you're going to maximize each one and use as much resource as you possibly can from each, then absolutely, it's going to be the most cost effective. If you're only going to use a bit of it and you've still got a lot of idle resource usage there, this probably isn't the most effective. And there's a huge learning cost involved upfront as well. And with that, I'm going to bring my time to a close. I'd like to thank the organizers of Virtual Azure Community Day for having me back again. I think this is my second or third event. I can't quite remember. And also, thank you all for watching and joining in today. There we go.
Yeah. That was perfect timing, so thank you so much.
It was perfect timing. Thank you.
Yeah. I think you are so excited about this topic. We could have left you
I probably
for
could
like
have,
hours,
yeah.
Right?
I probably could have. I've got a longer version of that talk if you'd like me to just keep going. I'm joking.
Well, I have to admit, are we gonna just say it? I'm looking at Punima, but we're not even on camera right now.
Okay, how do I come in on the camera?
sit
Okay,
Come sit there.
let me come along then.
So this is not chaotic at all, or like
Okay,
a weird
yeah,
culture.
I'm here now.
Basically, it's like kind of like women taking over the studio. Do you want to join us too?
Yeah,
Absolutely.
Let's
just do it.
It's not
Yes.
even mic'd, it's not even mic'd up.
Because let's be honest. Yes.
This is like true community feeling, right?
It is.
It's everyone
Yes.
in the same room.
Exactly what we need.
Isn't this what community is all about?
100%.
Providing a stage for everyone to share their passion for technology. Still having Hank behind the camera.
Yes.
That's his favorite spot. But yeah, I think this was an awesome day.
I agree.
I think you're still so excited. You're still all here.
Definitely, yeah. I thought I had to leave, but apparently we didn't. So, yeah. But no,
It's
It
not
was very
confusing
nice.
at all.
Not confusing at all.
Please
yeah.
leave. No, stay.
Yeah. Well, I did definitely also like your talk, Callum. But
thank you.
I do still have a question because customers usually want to need auto scaling and stuff like that, but they don't like the automatic billing part. So, do you have any suggestions for that?
It's this. So the question, because Mike's not got Mark's not got a microphone on, was customers like the auto scaling, but actually they don't want to pay for it. So, what gives here? It's like the old adage on a project: they want complete flexible scope but fixed budget. It's never really that possible. Yeah. So you can of course put sensible limits in place, and I think another important thing to note is there's different tiers within all of these products where you can choose lower powered virtual machines or lower powered or higher powered app service plans. There's no way of automatically switching between those, but you could choose to distribute your workload nicely across the relevant platforms to get the best bang for your buck, if you will, when it comes to scaling. I think container apps is really exciting because the billing units are so small that actually the scaling is kind of macro, whereas with app service you're scaling up really, really large amounts of compute. So there's other options coming out for that exact case.
Nice. Yeah.
And yeah, doing stuff at night, making better use of your idle infrastructure is another great way of squeezing those extra few miles out of what you're already paying for. I guess.
Yeah. Clever. Okay, thanks.
Thank you.
Cool.
That
Thank
makes
you.
sense. It gets me all excited about all the new possibilities that are just in the corner. So stay tuned. No, but without kidding, I think it's time for us to wrap up, even though we would still love to party, probably taking it into the wee little hours of the night. But I think we gave you a great impression of how Virtual Azure Community Day is all about providing this awesome stage for the community to share our passion for technology. And hopefully we'll be able to invite you on this stage next time. And with that, I think it's a wrap. Right, Hank?
Yes.
Bye.
See you later.